Hi guys, welcome to topic 6.5, which is the binary covalent system. So we're going back to things that are made out of two elements, and we're getting away from binary ionic and into covalent, and I'll distinguish that here in a moment. So all you really need for today's lesson is your periodic table, might be useful, and then if you have the ability to print or open this file with the naming tree, if you had things mailed to you, this was one of the documents included in that envelope for you. So like I said, we're going to be working on topic 6.5, and you're going to see here on why it's called the prefix system here momentarily. And so everything that we've done up to this point is made out of a cation and anion, a positive, a negative, a metal, a nonmetal. And so that's when we have basically when an element's giving away electrons, an element's taking them in to get to that magical 8 valence electron configuration. There is one other way elements, not electrons, but elements can get to that octet. And this is a specific property of the nonmetals and metalloids. So those negative charges, this right-hand side of the periodic table. And then remember the stair-step line with boron, silicon, germanium, arsenic, antimony, Te, Po, and Ts. So those elements, as you head to the right, can do something different. They have the ability to share electrons. So instead of an element giving up and an element taking in, they can share their outer electrons to get to configuration 8. And that's what we're going to talk about more in our next unit. But because of that difference in how the electrons are dealt with, we have a different naming system to configure with all the different compounds that come from this style of electron sharing. So we use prefixes to identify the number of atoms that we have, because what we're going to see is we can have the same elements like carbon and oxygen, and depending on the ratio of the carbon to oxygen, we can get completely different compounds with different properties. And so we need to account for the fact we can't call them carbon oxide, and because again we have things like carbon dioxide, carbon monoxide. And so like I said, as we get into this, you'll see that we are going to use those same elements with a different ratio. So the prefix for 1 is mono, 2 is di, 3 makes sense with tri, 4 is tetra. If you've ever played Tetris, all of the blocks that drop are made of 4 smaller blocks if you pay attention, hence the name Tetris. Penta for 5, 6 is hexa, 7 is hepta, 8 is octo, 9 is nona, and 10 is deca. So some of those should make sense from geometry and things like a decade. So when we go to write a formula, there's a lot of things have changed with this system. So because we now are sharing electrons, charges are not part of the plan for naming. And so we use prefixes to become that subscript. And the last thing is we're going to have to get over that urge to simplify. And so here I've got 4 examples where we're going to go into the process of converting it into a formula. And so in this first one, we have tetraphosphorus hexasulfide. So the order that you see your elements are the orders that you're going to put it into your formula. So this first one I see tetraphosphorus. So my first element is phosphorus. So I put its symbol. My second one is hexasulfide. So that means my second element is sulfur. So the prefix here becomes your subscript. So because I have tetraphosphorus, that means I have 4 phosphorus atoms. Hexa goes for my subscript on the sulfur, and that is 6. Now the urge here is you probably want to simplify it down. So it's a 2 to 3 ratio. And so that isn't going to work here. You leave it as is, no simplification. So we're done. This next one is dibromine heptoxide. So my first element is bromine, and this prefix tells me how many. So I have Br2. Hept oxide. Oxide is my second element, so oxygen. And the prefix hept means 7, so Br2O7. I'm going to drop to this one down here, dinitrogen pentasulfide. So dinitrogen, so I know I have nitrogen, and I'm going to have 2 of them as well. I have pentasulfide, so sulfide is indicating sulfur, penta indicating 5. So N2S5. So this last one here, we have nitrogen trichloride. This one is different than the previous three examples in that there is no prefix associated with nitrogen. In this style of naming, there is only one scenario in which there will be no prefix associated with the first element, and that's when you only have one of them. So you will never, ever, ever see mono on the first element name. You will only see mono on the second element name. The first one will have a prefix 2 all the way up to 10, just never 1 for 1. So that means because there's no prefix, that is just one nitrogen. We have trichloride, so that means chlorine, and we have 3 of them. And that is all done with going from a formula to our name to a formula. Now the other half is going in reverse to a full name. And so there's kind of 2 parts that are going to be used when we go to name them. So the first thing is, what do you do with the first nonmetal or metalloid in the formula? And you're going to use a prefix and then name of the element. Prefix indicating the number of that specific element that you have. And then from there, you have the second element, which you're also going to use a prefix with. The thing with that is we're going to follow the same rule like we've done all along, is you'll use the stem of it and add "ide." So we will never have in the second element, for example, dioxygen. It'll be dioxide, for example. And this is like I noted on the previous thing, with the previous examples, mono will never, ever, ever be on the first element. If we do need to use mono, it would be associated with only the second element. So from here, we have some examples to go from the formula out to a name. And so this first one, we have P2O5. And so the thing with that, again, is we don't need to do anything with charges. So again, that's nice and handy. So we have our subscript here of 2 with the phosphorus. So that tells me what my prefix needs to be. So I have 2, so that's di. And then our first element is phosphorus. Do not change the ending on that first element. And so then our second one, we have 5. So this is where the English language is a lovely thing. And so we know 5 is penta, and oxygen will change to oxide. So technically it would go pentaoxide. Well, the double vowel there, that A and O, is frowned upon. And so we're going to get rid of that A. Instead of saying pentaoxide, we're going to say pentaoxide. Now, if this was on a quiz or a test and you put pentaoxide, I am not going to be that nitpicky and take off points for that. So in the next one, we have Cl2O7. So we have a subscript here of 2. So just like the previous example, we're going to use di, except we're now using chlorine. And notice no ending changes on that first element. The second one, we have 7, and it's oxygen again. So we have that hepta prefix. So like the last one, it's not going to be heptaoxide, but heptoxide. So here we have a subscript of 4. So the prefix for 4 is tetra. We can keep the A in this example because our element is going to start with a consonant, so phosphorus. So tetra, phosphorus. And then we have 10, so deca, and same thing, so it becomes decoxide. So the one thing is I'm going to have to think about how I print things out because writing is a little bit of a challenge. So I've been buying larger markers to write with my hands being the way that they are. So you'll just have to bear with me as I work through these new challenges. So this first one, or excuse me, this last one really is what I want to say on the left-hand side. Looking at the first element, notice there's no subscript. So I have sometimes students think that that means we have none of them. Well, if there was none of them, there wouldn't be any in the formula. We do have one, and it's one of them because there's no subscript. So this is where we would have monoxenon, but like I said, that's the exception to the rule. So really, there will be no prefix here, and we would just call this xenon. And then go with the second part. There's 6 of them, so we have hexa, and fluoride. So I just want to do one last example with you in this video. And that's this one here on the right, the CO. So for this one here, we have one of each because there's no subscript on either element. Like this example here, we do not put mono on the first element, so we just name that carbon. When we get ready to name the second half, however, the second element must always have a prefix, no matter how many you have. So this is where this would give us monoxide, which you probably have or should have a carbon monoxide detector in your home, because carbon monoxide, like carbon dioxide, is a colorless, odorless gas. And especially in the wintertime, this time of year, it can be problematic in the home, especially if you have like an attached garage, or if your furnace isn't maybe running quite adequately, and not if it's especially a natural gas style heater instead of electric. But anyways, that can become a problem in the home, and it is a gas that unfortunately can cause asphyxiation where you are unable to breathe. And so where I'm from in South Dakota, with it being as cold as it is, unfortunately, there's usually a tragedy that happens in the wintertime with a family because they didn't change the batteries or just didn't have a carbon monoxide detector, and there wasn't proper ventilation within the home. So just a little side note on, you should maybe check if you have a carbon monoxide detector in your house and maybe double check the batteries. So anyways, that is topic 6.5. If you have any questions, need any help, you know how to get a hold of me.